Sounds good. Thanks.
So I'll probably just speak into the podium like right now-ish and get everybody kind of back together, and we'll get started. Thank you.
All right. Thanks. Andy's fine. I'm hot.
Hi, and welcome to the second half of our day. We will have 3 speakers and then a brief 10-minute break for refreshments, and they really only keep them out there for about 10 minutes, so go and get them. And then following that, we'll have another few speeches and then the unconference session. So for our first talk, I'd like to introduce Andy Dawes, who is talking about teaching quantum mechanics with Python, but I think he goes deeper than that. So I hope that you enjoy his talk.
Thank you. Yeah. Yeah, so we will get into some quantum mechanics, but not to the extent that anybody should really be afraid of it. But just so I know, who has taken a quantum mechanics class at least before? Okay, a few, not necessarily recently, that's okay. How about if you've taught a class with Jupyter before? Got a few. Okay, so we might have some familiar content. So my emphasis today was really on sort of teaching anything with Python. Just a little bit about me real quick. I'm from Pacific University. We're just down the road in Forest Grove, about 20 minutes away from Portland, at least depending on the traffic. My research is in quantum optics, and so this really works closely with my familiarity and expertise there, but I've been using Python as long as I've been doing quantum optics, so it's really nice to finally get to bring them together. And this is about a class that I've offered for the last 6 years. We offer it every other year, so basically the last 3 times I've taught this class, I've built in more and more Python. And so my hope is to really just talk about teaching anything with Python so that this could be content or topic neutral. There's of course going to be specific examples of how I took Python and brought it into the classroom, but I also want to encourage you to generalize anything I've done to using other computational frameworks and really take advantage of what we have access to with this Jupyter and Python and GitHub kind of workflow that we've made use of at Pacific. So of course Jupyter is going to be a central piece of this tool chain. If you're not familiar with that, I'm sure you've at least heard of it, but if you haven't, you should definitely check it out, and we'll hear a lot more about that as well in the next talk in particular. Sure. In particular about how to use it at a larger scale sense in a classroom environment, and I'm actually interested in finding out more about how to do that myself, since that's one of the things that I didn't dive into yet much. So of course Jupyter you're probably familiar with, but if not, it's really now getting ubiquitous. I don't know if it's totally ubiquitous, but I certainly run into it anytime I talk to folks about interactive computing. It's this workbook-based computing environment. There's a really good supportive active community, and because it's started from the IPython project, it has grown up with a lot of self-help built in, which is really classroom friendly because students can quickly find access to questions or answers to questions that they come up with on the fly, which, you know, students these days, especially anybody that's working with students, are used to how fast they want an answer, and Google is usually the first place they'll go, but this is actually even a little faster than that because you don't even have to fire up a web connection necessarily. And it's also self-documenting, so we've used that to a certain extent, and I will give a disclaimer that my notebooks are not anywhere near as pretty or complete in a single volume set as some others that are out there. Certainly Lorena Barba's stuff and things like that in computational fluid dynamics are really stellar works, but I'm trying to aim for filling in sort of a different niche that's not necessarily creating a standalone reference, but really augmenting what's out there in a textbook. So you've already adopted a textbook for a classroom, or you already have a lesson plan that has a lot of reference material in it. How can you mesh that with Python, and how can you leverage some of the strengths of what's out there in the Python ecosystem? So this is like an example of a typical notebook. So again, nothing crazy in terms of formatting, but kind of a worksheet that students can go through. They can pull this up, and I don't hide from them the fact that you have to import things in Python, and we try and use sort of industry quote-unquote standards for naming conventions and things like that. So they're used to the fact, and I encourage them from the beginning that I'll tell them that one of the final exam questions is going to be how do you import features that we need for these classes. So they'll pay attention to that, because that's something that, if they forget that, they really are going to be kind of dead in the water. But we do a lot of this stuff in class as well as in a lab time, and I'll talk about some course details when we get down to that. And so we have these students working through these notebooks as a supplemental exercise, necessarily, sort of like they would do their homework. And the main features, of course, that I use are just the fact that you can do inline graphics, so they generate their graphs in real time, sort of all in one document. That's familiar to them because we've, prior to that, used Maple and Mathematica a fair bit, so that whole feel is very comfortable to them. Of course, Markdown, we don't really get into too much crazy formatting, but just the fact that they can actually highlight text, and they can make it a title or subtitle or things like that. But I do make fairly heavy use of both GitHub and just so that I can post files for students to download. And they're comfortable downloading a file after the first day and firing up Jupyter Notebook and getting it to work and opening up and seeing what they're working on in the class. The other piece that may not be as familiar to folks here in this audience is the Quantum Toolbox in Python, or QTIP. And this is a really great framework of routines that are defined in Python for doing lots of different quantum mechanics. It really started as a mimic or a rewrite of the quantum optics toolbox that was a MATLAB toolbox for doing quantum mechanics calculations in MATLAB. And of course, now it's open source and free because of all those good things that come with being open source. And that has a lot of the features that we use in the class as well. And I will say that what's kind of key to this, as far as tying a framework into a classroom experience, is that it's not a toy. This is not just a simple set of functions that I've handed to the students that does exactly what I want it to do. This is real life, full power computing framework that people are publishing papers using the calculations they generate in QTIP. And it's under active development. There's an active listserv and chat rooms and things like that provide question and answer functionality for this project as well. It gives us a lot of convenient object definitions. I mean, that's kind of the sense of what good is a framework in Python. Well, it defines these common functions and common objects. But the nice thing about it is that there's lots of existing examples out there as well. Just like Jupyter, there's lots of good examples of Jupyter notebooks that you can pull up, or Matplotlib. If you're first learning how to make graphs, there's lots of good examples and galleries out there. There's a lot that's available for using QTIP as well. And that spans from kind of the basic intro level all the way up to some pretty high level calculations, not the kind of thing you would necessarily throw at undergraduate students. But what I mean by standard objects is that this kind of puts quantum mechanics into the same category as some of these things that you could get, like from NumPy importing pi, or from the SciPy constants library importing the speed of light. All these other things that are kind of becoming more available by these libraries that Python has available to us. We can now import lots of standard quantum objects, and not the physical sense like an electron or a proton, but the programming sense. Like, we can import a quantum object that defines and represents a quantum system or quantum state. And what's really key is that these are just the exactly same objects that the students see in the textbook. So if you're learning quantum mechanics as an undergraduate, it's really cool to see this framework that defines the same things that you're learning about as mathematical objects, and you can handle them the same way. And so that's a really powerful tool in the learning paradigm. As a couple examples, again, if you're familiar with quantum mechanics, these should ring a bell. If not, we have a couple standard things like a Pauli matrix that comes up over and over again. It's just a 2x2 or a 3x3 matrix. I've shown the 2x2. Those are all defined in QTIP, right? So you can just load those up. Basis states, again, this is really just linear algebra. So even if quantum mechanics isn't something you're familiar with, you're probably familiar on some levels with linear algebra, and quantum mechanics makes strong use of that. In particular, the textbook that we've adopted is heavily based on the matrix methods. And so things like basis states, if you want to describe a complete basis for a system that you're describing, then you need to lay out all these orthogonal vectors, and it does that for you. You can say, I want a 2x2 system, and I need the first basis state or the second basis state, and it just spits it out as a vector. or the things like the density matrix. This is a thermal, the density matrix that would represent a thermal system. Again, quantum mechanics details you don't necessarily need, but it's defined in most textbooks, and then there it is. You can just import it. It's already done. You don't have to tell students to code in a 5x5 matrix and put in all the parentheses and commas and stuff like that. So it's really nice when they see the power that's available at their fingertips. It does also come with lots of powerful numerical solvers. You can solve Schrodinger equation really easily. You can solve the Lindblad-Master equation using lots of different kinds of operators, and even Monte Carlo methods, which are all, again, sort of more higher level quantum mechanics approaches, but it's evidence that it's a really complete framework as it is, and you can sort of turn students loose on it, and then they can really take it and run with it if they want to. We also use a lot of the visualization tools that are available and built in, and you can tell most of these are built on Matplotlib, so you can easily visualize different quantum states. And I'm not going to get into the details of what these really represent, but lots of nice defaults. You can make pretty pictures. You can visualize what you're working with. This is a nice example of visualizing a matrix. You can see the magnitude and relative phase of different terms in a matrix. Phase being the complex number aspect of phase. And so there's lots of ways that students can leverage that tool set as well. And then this is a three-dimensional representation of a quantum state. Again, just kind of nice, really well-built, accessible visualization tool. So you don't have to reinvent the wheel with all that, and it's all there already. So enough about those two. The specific format, the implementation in this class, takes a couple levels. First, it's the junior, senior level physics majors class. Again, this is undergraduate students, so they've taken a pretty full set of classes already before this. There is no computer science experience required, so they're coming in without necessarily having had any coding experience. About 50% over the last few years I've taught this have had an intro level C++ class, so they get the idea of for loops and while loops and stuff like that, which turn out to not really show up much in what we do. They can use them in some cases, but it's really mainly what they get from having that experience is a little bit of confidence opening up either a terminal window or writing a script or typing some code in and clicking go and not being worried about breaking the computer or something like that. Of course, it's very hard to do that, so nobody should worry about that, but they're more confident when they start out, but we get everybody up to speed pretty quick. This is about 14 to 18 students, so we do benefit from having a really small class size, which I would imagine makes it harder to scale something like this up to a really large classroom, but there's probably ways to do that. And this is a picture of the class that I teach in. It's actually set up for electronics during the picture. That's why there's power supplies everywhere. But there's computers essentially for every pair of students, and so we often let them pair up, and they'll do partner programming kind of approaches to getting through a worksheet. And they'll answer questions, and they can turn that in and run their simulations as they go through the class. And this is run in 3 65-minute sessions per week and 1 3-hour lab. So we do have a 3-hour lab period dedicated to our quantum mechanics class, which is nice. We tend to use that for a mix of more deep dive numerical work or actual experiments. And we do have the advantage of using some actual quantum experiments in our class. But the textbook that we're using is by Mark Beck, called Quantum Mechanics, Theory and Experiment. The experiment part is what I referred to, that we do actually have a few experiments that we get to do in the class. But the most important part for the context here is that this book is based on the matrix mechanics approach to quantum mechanics. And that is really what I was saying earlier, that this really makes a lot of use of linear algebra, or you may have heard it as Dirac notation, where you represent the state of a system as a vector, and that vector will evolve in time by having operations act upon it, and those operations are represented by matrices. So just to kind of put a little bit of context in that, we often start off with two-state systems. So you think of a system that can pick one of two states. It could be like a spin in a magnetic field, where that spin, like the electron, not actually rotating but has intrinsic spin, that could be pointed either up or down. Those are the two choices. Or you could think of a hydrogen atom, the electron in a hydrogen atom. It could be in the ground state or the first excited state. That's two states for it to choose from. And photon polarization, if you're talking about a photon that's flying down through empty space, vertically polarized, or horizontally polarized. Those are two different states, and then you can write any combination of those as a linear combination of horizontal and vertical. But the math is all actually the same. For those three systems, the math is all identical, and it's all just 2 by 2 matrices or 2-element vectors. So the states of those systems are all represented by 2-element vectors. And again, you could just say, well, we'll define one of these as spin up and one as spin down, and that's just using that basis state that QTIP defines. And so day one of using these notebooks is orienting students to that idea, that you can see these vectors that we've talked about in reading the book, and now you just get to load them and import them like this, and they do all the things that you expect them to do. And of course, like I said, you can generalize that to the other types of systems. That could be the ground state or the excited state of a hydrogen atom. All the math is the same. And so it's important to recognize what's universal and what is state specific. Like I said, operators then become matrices. If you're in a two-state system, then your matrices are going to be 2 by 2. If you're in a 3-state system, they're 3 by 3, so on and so forth. So something like a rotation matrix looks like you might expect, and you can define that. And I've just prior to this, defined a function that takes a certain number of radians and spits out the right rotation matrix again as a quantum object, so QTIP knows what it looks like. And you'll see that QTIP tracks the dimensions for you, and it makes sure that you're not trying to do something silly like multiply things that aren't the right shape and stuff like that. So it provides a lot of student-proof feedback for making silly mistakes. Something like changing a basis, if you want to write, instead of writing in the horizontal and vertical basis states, you might want to define 45 and minus 45 as your basis states, so you can define the matrix that converts one basis to the other. All these things are really pretty straightforward in QTIP, and so it takes a lot of the mental headache that students might be trying to overcome if they're not as comfortable with linear algebra, or maybe they're not as comfortable with the computational side of it. It really makes it pretty easy, because all they're writing out are sentences that just look like what they've seen in the textbook. They just need to apply certain operators in certain orders, and they'll see what they generate. Yeah, exactly. No worries, no quiz even. Don't worry. And if you've heard about bracket notation at all, that's all built in as well. And essentially what that means is that some states you want to write as a column vector, and some you want to write as a row vector. Again, it's all just linear algebra, and this is all built in as well with QTIP. If you want to take what would be called the dot product in linear algebra, that physically represents the overlap between two states in quantum mechanics. Essentially the probability, if you start out in one state, of measuring the particle in that same state, you would take the dot product, or in this case B times A, and you get 1. So those overlap completely. If you wanted to take the outer product, you sort of do that in the reverse operation. And this is all built into the notation that students are going to be familiar with from a quantum mechanics class. And so you don't have to think about it too hard like you would if you were using sort of standard NumPy vectors. Like, you'd really have to keep track of which one's a row and which one's a column vector, and it just sort of does it right for them, because all that matters is the order that you multiply these. All right? So you're really using a lot of those powerful features. So we're not going to get into any more deep quantum mechanics than that, but you can already see what this benefits the students is that they can suddenly jump into much larger problems, right? You would not assign, I mean, at least I wouldn't. I would never get teacher evaluations back if I asked to assign this problem. Like, to do a 10 by 10 matrix by hand, like, it's just not tractable. But it's very easy, and that's exactly what computers are good at, is doing these large problems for us. And so they can learn in a context that's familiar to them, and then very quickly generalize to see some very powerful, very large systems that they get to kind of expand their expertise without paying an extra price of all that pain they would have to go through. So again, this framework really exposes the students to these large-scale systems, which are, of course, the ones they're hearing about in modern results, and they have a lot of practical relevance. So it's a tool that they get to tie to what they understand and then jump off of once they get into it. Yeah. Yeah. The result of the calculation is, I guess, like what you're seeing right here, you mean? Oh, yeah, I mean, so that's, yeah, I mean, I'll flip to a live Jupyter Notebook later. But yeah, I mean, these are Jupyter Notebooks, and they just sort of render. Let's see, make sure you're seeing that. I'm seeing. Yeah, they'll render a matrix, sort of all built in using LaTeX. So it does so in a nice way, and you could. I don't know that I could copy and paste that as an image, but you can certainly screenshot, and that's what I did to get back to these. Yeah, and we'll do a little bit more nuts and bolts of that here in just a second. Yeah. So I want to get away from the quantum mechanics and really focus on the role of the notebook in the class. Like, how did I kind of frame this within the context of a class? And so the idea was to have kind of a chapter-specific notebook, again, sort of one notebook per chapter within the textbook, and include the definitions and the techniques that are relevant to that content. So this is kind of where you could imagine morphing this onto something that you're teaching or that you're even in a classroom learning, and take things in the textbook and start to bring them over into Python. And so a couple of really useful things are to have solved problems that the students can see, right? They're going to be asked these homework problems, and you can actually do a solution to a problem in the notebook and show them how that would look, right? What are they going to have to do to actually solve that problem in a notebook? And you can also, I think this is really helpful, recreate examples that are in the textbook, because the example is worked through for the students to read, but then you could also recreate it, sort of the Python version of it. And they get to see how does the sort of algebra that they're learning map to commands in Qtip. And the nice thing is that mapping is actually pretty transparent. And there's a lot of cases where that's not going to be true. So again, picking a framework where that mapping from the notation the students are learning to what they're actually going to write in code is important. And then we also use it in what I'd call the labs, right? We have this larger 3-hour chunk of time where we can really dive into a particular topic. We're going to follow the chapter content through. Again, this is the time where I would include chapter problems they could work through. I'd maybe start out, show them 2 examples in the notebook, and then ask them to finish out a few chapter problems. And then we also get the opportunity to turn them loose in an actual lab, and they do some single photon counting experiments. So this meshes in well with that. But I realized I wanted to flip back while we were here with these 2 and show you some examples of what I mean. So I'll flip over to my notebook for chapter 4 and just kind of skim through this so that we can see what I mean. And I'll zoom this in a little bit. Oops, wrong screen. Let's go over here and zoom. All right, so without blowing things away, I'm going to hide some of this stuff. You know where we are. Right? So again, they'd kind of come in and I'd say, well, download this notebook, fire up Jupyter, and we're gonna follow through. This is again after several weeks of doing this kind of thing. So run the standard imports. Let's talk. We're talking about photon states here. So again, this is how this book happens to start out. Is that instead of dealing with bizarre quantum systems, they're talking about photons, and those are polarized horizontally. That's represented by one basis state. They're polarized vertically. I just did this for horizontal. This would be horizontal. This is vertical. Plus 45, minus 45, right circularly polarized, left circularly polarized. Again, if you're not familiar with optics, those are just the 6 possible ways a photon could be polarized, and we write them in as these vectors. And so they start out with those standard definitions, and then work through ways to manipulate those in the framework of Qtip. And so they've learned about a particular matrix transformation that they can apply. So we write that in as a defined function for Python. So they're getting exposure to this, but they're not asked to write that from scratch. That's something I provide to them, and they get to see kind of how that would work. And they see, well, okay, this kind of makes sense as we go through line by line. And so this is one of these cases where I've got an example problem that's worked out. This problem in the book says, let's express this rotation operator in the plus and minus 45 basis. So they've got to convert an operator that's a matrix into a different basis, and that's a standard linear algebra operation, but they can see how that works by taking this RP function definition, where that's kind of what they have to come up with. They just code it in, write these 4 terms for this matrix. Qtip has this nice little tidy up function that just sort of gets rid of things that are actually really close to 0 instead of hanging on to 10 to the minus 19 times terms. and then gives you a quantum object back. And so then you can kind of see how that would work. And they can plug in some examples from the book and make sure that their matrix looks the way it should and things like that. And that's just sort of a mechanics level question. That's not really applying it to anything. But they get to see that what they're doing maps directly to what they would be doing by hand. And these are all problems that they could do by hand. But the point is they can do them by hand next to doing them in the notebook and see the commonalities and then get that connection built up until they're ready to move on to more advanced topics. Similarly, like for this chapter 6 notebook, again, these are analogous to the photon states, but now we're talking about spin states, and so we've defined a couple standard spin states. Again, those would be in a lot of physics textbooks that would just be defined a certain way as vectors. And so, since that's not totally obvious, I can just run this and we'll see what I'm talking about. Like if I looked at a spin that was in the plus z direction, that just happens to be that vector we saw before, 1, 0, right? Well, what's the vector that represents a spin oriented in the plus y direction? That would be this 0.7 and 0.7j, right? So it's a complex vector. So they can go through all the same calculations. For example, determining the probability that they measure. This is quantum notation for if you start out with a spin in the minus y direction, what's the probability of measuring it to be in the plus x direction? Right, so basically, if you start this system off oriented like that, what's the probability you make this certain measurement later on? Right? So you've heard a lot about quantum mechanics, this uncertainty principle probably. That's really what this is getting at, that basically you get 50% likelihood of making a measurement on a particle that starts out pointed one way, being pointed a different direction. And those probabilities depend on that initial state. So you can recreate all those calculations, and then some more advanced ones like these other more advanced relations that you end up running into in quantum mechanics. And so there's all those things that students get to dive into really well. So how are we doing? Okay. So I want to get back towards the end of this. This is just a quick picture of those photon counting experiments. Again, that's just sort of some other context. The really cool thing is that then the students can dive into these more advanced numerical experiments and really take advantage of a lot of the built-in solvers and the visualizations that they get to see. And that would be the kind of thing that I've got in this example notebook here, where they're really taking a little bit more programmatic approach. They're having to start to get familiar with defining functions on their own and writing in good programming habits, commenting things, defining their own variables in a smart way, that kind of stuff. And so then they can really extend those and get some cool results. And in fact, this is actually like the recreation of a book figure, and so they get to see what are the parameters that went into that and draw connections to the quantum mechanics that are happening underneath. So I will wrap up with that and say that the pieces that I want you to take away from this are that you can kind of go and do this, right? You can Pythonize your favorite course textbook. I'm working on doing a similar thing with my thermal physics class currently. So I'd encourage you to post any notebooks or code you develop, and also tag these and be descriptive and share it and publish it everywhere so we can all find it. Because if we build up that big library of all of these resources, you don't even have to go to contact the author of the book. You just say, look, I'm using this book. Here are these cool resources, and people are going to find it and use it. And so if you want to do this, I would say find real-world frameworks, right? Find like AstroPi is another good one. QTIP I've really enjoyed using, but the ones that industry professionals are using, right? Teach your students to use those because that's what they need to go out and get a job. Recreate the examples so they get to reinforce what they see in those references. And don't be afraid to give out fully worked examples. And I think it's useful to read code that works, right? And you don't have to make students code it all from scratch. And you can hand that to them and then encourage them to just tinker on what they want to change. So thank you for your attention. I'm happy to answer questions if we have any time for them. I've got some credits here, and if you want to know more about this stuff, feel free to contact me. Thank you.
We have time for one really short question.
Sure. Oh, no worries. put it on me. Sure. I mean, I have them, I tend to have them, two things. In one class, I had them just email me the IPyNB file, and then I sort of put them in a folder, and I run my own notebook and open them up and grade them. More recently, I've started letting students or forcing students to learn GitHub, and so that they'll pull and they'll maintain their own little repo, and they'll run it. And then I can just clone it and grade things there. And that's been nice too, because then I can actually, for their final projects, I can go in and make a pull request and say, look, you need to fix this stuff, and they'll merge that, and then we can kind of go through that process as well. That's totally not related to quantum mechanics. I wouldn't expect people to need that skill when they leave a quantum class, but it's really useful now in a lot of levels. And they're seeing that in high-level physics research. LIGO, for example, is using GitHub and notebooks all over the place. And so they're going to need it when they go out into the world. So yeah, those are the two techniques I've used. Yeah. Another question? Or are we good?
One quick one.
Yeah.
I'm very interested in interactive systems. I've been interactive in the sense that you can type in some expressions and it will give you the results, but you cannot interact with the results. Especially visualizations, like where do you see the value of that, other than explaining the end result.
Right.
How do you get through the different steps when you interact in that analytical process?
Right. So they do a little bit of iterative work in terms of, you know, that they've got to build up these calculations, and so they've got to define the different components along the way that they're going to need that represent what they're learning in the book. And so it's not necessarily like run a simulation and then move a slider around or press a button or something like that, but they're at the point where they're trying to test and design and then test all these objects that represent different calculation components. I have done some work in the thermal class of doing a little bit more what you'd think of as interactivity. So they could say, well, let's make a PV diagram of a system, and then let's move the number of moles of gas around and see what happens. So I think that, it's amenable for some topics. I haven't yet worked it into the quantum as much. Yeah. All right. Thank you.
Or maybe not. I don't know. I think so, yeah. Oops. Can I use this HDMI?
Yeah, absolutely.
I might not.
Yes, okay.
No, well, hang on. All the trade secrets. Now, I want the...
What you see here is what's up there.
Oh,
So you can just look here.
but I don't want them to see the presenter notes.
You'll only see those here if you're set up that way. You have to start the presentation.
Oh, duh.
Yeah.
Okay.
So, well, right now you're mirrored. You can unmirror. Let's go to your display settings.
See, technical. You want to do it for me?
Sure.
While he gets my technical difficulties sorted out, how many here is it their first Python? Wow. Welcome. Welcome. And for those of you that have been to PyCons before, welcome back. For those of you that don't know me, I'm Carol Willing. I'm actually on the Python Software Foundation board, and we are really happy. Do you mind if I move that mic down so if I'm standing behind the podium, it's not right in my face, being short? All right. Yeah, I just got to find my clicker. All right. Let me know when you're ready. Are you guys ready? Okay, I have no idea if this presentation is 4 hours long or 30 minutes. So, yeah, you're my hook. And should I not cover everything that you want to hear, I am happy to do an open space later in the week. So, all right. Good? Okay. All right. So, I'm Carol Willing. I'm one of the core developers on Project Jupyter, and I work at Cal Poly San Luis Obispo, and I want to welcome you to the Education Summit, and I'm really excited to talk to you about Jupyter, JupyterHub, and education. But first, I want to say thank you to all of you who take the time to help other people learn, to the folks, Jess in particular, who organized the Education Summit, to the volunteers, to sponsors, and anybody who's helping in any way. It is really important, and this is my absolute favorite event of PyCon, which, not that I don't like all the other ones and I run the tutorials, but this is my favorite event because this is what allows Python to grow and grow in fabulous directions. So, what we're going to do today is we're going to spend a little time sort of defining learning in the context of this presentation, a very brief amount of time talking about Jupyter Notebooks and JupyterHub in terms of architecture, primarily because there are many presentations already out there on the architecture, and I really wanted to focus in on some principles of learning and how you can use JupyterHub to increase your impact in education. And then we'll talk about some next steps of where you can go after today. Okay, so a few years ago, probably about 5, I got involved with a nonprofit called Open Hatch, and that's Sufjan. He was our little mascot, very cute. What we were was a nonprofit that went out and taught people how to make their first contribution to open source. And we did events on different college campuses called Open Source Comes to Campus. It is also all the materials are open source, so it was sort of pre-software carpentry, data carpentry, if people know what those are. And one of the things that I really learned was how to get people beyond their fear of trying something new, how to encourage. And I came across a really great book that is published by some folks from Carnegie Mellon. Herbert Simon was one of the real innovators of cognitive science, a Nobel laureate, and a professor at Carnegie Mellon. And in his research, what he found was learning is really a result of what a student does and what they think. And to contrast that, as a teacher, what you can do is you can influence or guide learners, but you can't do it for them. So it's sort of, sometimes we think, oh, we can give them all the knowledge they need. Not exactly. There takes some work on their part as well. And often as teachers or educators, we don't know the impact we have on people, and we don't always get feedback as to how we've done. Occasionally, we'll find out 3-4 years later that somebody that I did an open source comes to campus event at Claremont Graduate School, probably 4 years ago now, went on to make her first pull request and is now speaking, and I had a chance to be at the same conference as her. It was really cool because I had no idea that this had happened in her life since then. So what you do really matters. All right, so really quickly, Jupyter Notebooks, and some of you might know it as IPython Notebooks, and JupyterHub are fairly young projects that have seen tremendous growth recently in science, data science, and education. Fernando Perez, Brian Granger,
and the entire Jupyter team have really taken Galileo's concept of notebooks and brought these notebooks to life and made them accessible to many people from many different disciplines. And we'll talk a little bit more about that in a few minutes. One of the things that really motivates me, Luciano talked about it this morning, but it's that ability to learn and try and share something and be excited and explore. And for me, my introduction to that was an Apple II computer a little bit before Luciano, so maybe late 70s. I was a 7th grader and was kind of a math geek, but also a soccer geek, so go figure. And I loved art. And I was in a special pull-out program that I had to be in, that I didn't want to be in. So I was kind of a rebel, too. But our school had just gotten, much like Luciano, a new Apple II. And still in the box. And I'm like, okay, I don't want to play Dungeons and Dragons. Not that I have anything against it, but as a 7th grade girl, you could imagine, with like 4 other guys. It wasn't what rocked my world at that time. So I said, I'll unbox that, and I'll try and play it. And I did like video games. Atari was a big thing there. And I figured, oh, I'll make a simple game. Anybody remember Pong? Okay. Anybody remember Breakout? Breakout had strips of colors, for those of you that might not know, and a square ball that you would use to chip away like pieces of the wall. And basically, I tried to recreate it, and I did. It probably took me 4 months on the Apple II. And to me, it was this exercise in exploring and kind of trying something, failing, trying something else, failing, succeeding. And that was sort of where my love of computers started, but even more so my love of education. And back in 2013, I had attended a tutorial that Luciano did right when he was writing his Fluent Python book, and decided, yeah, Python seems like a pretty cool language. Maybe I'll get more involved in it, get more in depth in the technical side of it. And so usually when I learn a new language, I try and apply it to something that rocks my world outside of programming. And many cases, it's music, art, or nature. And I stumbled across a music theory library called Music 21, done by Mike Cuthbert at MIT. And he was using IPython Notebook in the early days, where it was kind of a challenge to get it installed. But once you had it installed, it was really cool. You could do really cool stuff, like do analyses of like all of Bach's concertos in like only several lines of code. Or you could take a common song and render the sheet music and then translate it into Braille, which I thought was really fabulous. And at the time, I was also doing outreach at Fab Lab in San Diego. And Fab Lab is a makerspace. It's nonprofit, very community-oriented. It actually started at the Center of Bits and Atoms at MIT, and we were one of the first ones outside of the MIT area. And what I started doing was I'd have this open, and people would see it, and they'd be like, that's really cool. How do you do that? And I realized, like, people got hooked, and people got excited about it. And even more importantly, I got that excitement that I had from that Apple II computer when I played with these notebooks. And I call it played because it was just, you know, putting stuff in, seeing what would pop out back, being able to annotate stuff, being able to share stuff. And the power of the notebook is somewhat in the browser because on one level it is a web app. And what it can do is it's language agnostic. It can run probably 40, 60 plus, I can't even remember now. Jamie, you might know, languages. But the Project Jupyter core team develops the IPython kernel, and the community, which is all of you, develop and maintain all the other language kernels. And basically, we have a little notebook server that runs for each instance. So if you were running it locally on your computer, you'd have a little web server running, and it would communicate to the browser, and you would interact with the notebook itself. JupyterHub is really the same. It's basically giving notebooks to a group of people, whether it's a user group, a research group, a classroom, an entire city. Okay, maybe that's a little exaggerated, but and what's really nice is it makes it accessible in a different way. You don't have to install anything other than having a web browser. You don't have to have a laptop computer or a desktop computer. You don't have to install anything. And for those of you that have taught workshops where you have to install on Linux, Mac, Windows, it can go smoothly or it can go horribly wrong. And it's very stressful as an educator to have to maneuver people through install problems while trying to teach, and it's very distracting and it's frustrating for the student as well as the instructor. And I kind of view it as many times that's where people kind of say, yeah, I give up, this is too hard. So JupyterHub lets you kind of get rid of the yucky stuff and get people to the learning quicker. And the hub itself basically manages authentication of users, because you wouldn't want Kojo over here using Jess's files unless Jess gave him permission to do it. That would not be cool. And then the hub also maintains that database of users. It also has what we call a spawner, which will spawn one of these single-user notebook servers for each user on the hub. And you could think about it as giving each user their own little notebook server, and that really the hub is just a factory for providing that notebook server to each student. Okay, so we've talked about sort of some of the basics of learning, the basics of Jupyter and JupyterHub. I want to switch gears a little bit and talk about some principles of learning that Herbert Simon had written in a book, and he had 7 of them. We're going to look at 3. In this photo here, I think you'll probably hear some additional stuff maybe from Tony in a little bit on this very fabulous board, but this is Lamore Freed, who is probably the best electrical engineer I have ever come across in my life. She is technically amazing, but even more than being technically amazing, she is a phenomenal educator. She is passionate about it. I've been following her tutorials since she was a grad student, and I was an electrical engineer as an undergrad, so I was like, oh my gosh, she explained it so well. And I'm not going to steal Tony's thunder, but there's some good stuff coming there. And I think one of the things is the notebooks give you a way to spread knowledge quickly and to a wide group of people. So there are basically 3 principles. If we say Sifjan's one of our students, one of many that we might have in our course, the first thing we need to do is find a way to motivate the student. As an instructor, that is our responsibility. We want to provide them with material that sparks their curiosity, that engages them, that connects to something else in their life and their own experiences, and ideally has some sort of wow factor. And a lot of times you can do that with the notebooks because You can tailor content to a student. You can do these powerful visualizations or audio, text, running code snippets, and get instant feedback. So that's really kind of powerful. So then the next level, if we're going up our little learning mountain, you want to help them develop mastery of different concepts. And this is where some of the traditional installation issues really deter people from mastering a concept or a topic, because if it's frustrating to the point that you don't know whether it's installed correctly or not installed correctly, you're not getting great feedback, you're not getting the ability to attempt things in a controlled, safe environment. All of those things, as you're learning, are places where people can opt out. And if what our job is to guide people, when they opt out, they're lost to us as students, at least in the time being. Now, one of the great things is if we can motivate them, we can re-engage people who've had the door shut at some point in their life or don't think that they can do, whether it's programming or a topic from the arts, humanities, science. And then the highest level is really when a student has acquired knowledge and is able to apply it in a real-world situation. And what's interesting about these learning principles is they're not domain-specific. They don't depend on a student's experience level. And it also works in cross-cultural situations, which is a pretty powerful thing as an educator because you can take people at different levels and help them be successful. So what we're going to do now is look at some actual uses out in the wild of JupyterHub, and JupyterHub in particular being used at scale, whether it's a workshop or different classes. And I had a really hard time distilling down which ones I was going to show. So there are many more than what I'm just going to show you, and we would love to hear about anything that you're doing as well, because it gives somebody else ideas. Why reinvent the wheel? And we're going to see some best practices. What we're going to first talk about is that motivation level. And one of the things that we provide as a project is a gallery of interesting notebooks. And this you don't have to scribble really frantically. I will give you the slides later, probably not until tomorrow morning because I want to check the attributions. But you can work within the student's interests. So the gallery of interesting notebooks is everything from music, art, economics, science, quantum mechanics. I wish we had that when I was doing my engineering education, because that was one of the hardest classes to visualize what was going on. You also have access to something called NB Viewer, where you can actually put in the URL of a notebook on GitHub, or there's a number that are already there, pull it up, see what people are doing. And then there are two very valuable services. One is TempNB. We actually use TempNB in our try.jupyter.org. So if you haven't had a chance to play with the notebook yet, I encourage you to go to that website because you can play around with some toy examples, make some of your own. And then there's also Binder. And Binder is a service that lets you, as an instructor, upload a bunch of GitHub notebooks or notebooks in a GitHub repo, and it will serve it to people that then go to a link that it provides, which is really nice. Okay. So another way to motivate people is to start with a proven curriculum. And I think Andrew touched on that. In the Python community, Intro to Python, Jessica McKellar has a fabulous workshop that she's done many, many years, and had worked with me on OpenHatch. So I started playing around with these notebooks, and this was probably 2014 maybe. And I said, why don't I take Jessica's Intro to IPython, or Intro to Python, and translate it into IPython notebooks so that students would have the notebooks when they were done with the workshop. Instructors could use the notebooks to teach from. And then the next time we wanted to run a workshop, it was already done. So, motivation. Those people in that room spent probably 10 hours in that room. It was about 90 degrees out in San Diego. The room we were in had no air conditioning. The fans were going all day long, but miraculously they stayed. And I don't think it was just for the food. So one of the things that people liked was the ability to have that hands-on really quickly and get that instantaneous feedback that what they were doing was productive. And as a takeaway, the notebooks kind of reduced the stress level. You know, if you were trying to get a certain exercise done within an allotted time frame, but it took you a little bit longer than your neighbor, you didn't have to feel bad because you knew you were going to be able to take it with you when you were done. Okay. And then the third thing to motivate people, I think, much like Luciano did, the physical real-world meshing of learning, of programming, is very powerful because you can actually solve problems. There's a professor at Harvard called Demba Ba, and he did a wonderful talk at SciPy a couple years ago on how he took students who weren't programmers, who were sort of at the start of their electrical engineering career, gave them some wearable electronics parts and things, and basically had them build real-world self-directed projects. Students loved it. It had surpassed whatever they had done before, and it was highly successful, so it's worth taking a look. So now if we switch gears to mastery, Kristen Thing is a professor of oceanography and geoscience, and she has used NB Grader and written a really good blog post on it. And somebody before asked a question about how do you grade these notebooks? NB Grader lets you distribute notebooks, collect notebooks, grade it, but either manually or auto-grade it. And I would encourage you to check it out. And she also has some really good stretch examples. And in the interest of time, I'm not going to run that simulation, but if you click on the link once you get the slides, it actually moves in time. And you can actually see what's going on with the coastline. So it's actually really pretty exciting. And she walks students through how to do it. Oh, maybe did it start flashing? All right, so much. Okay, well, technology is not my strong suit. Another excellent resource for both high-quality teaching practices with notebooks is by Tanya Slusser, who actually has written a book with Kenneth Reitz on the Hitchhiker's Guide to Python. She is just a very, very smart person in data science who's done a lot of teaching. And what she found was having a flipped classroom format where the students read some stuff and then try stuff, and then have bite-sized lectures with then worked examples and then time to do in-class exercises is a really powerful way to motivate students and to help them learn. Some of the benefits are that the libraries and data sets can be preloaded when you're using JupyterHub or TempNB. You can have simple questions that students have answered quickly within the class, and students can actually help each other. So you make it a more collaborative learning experience. So I highly recommend that. And then another developing mastery at Cal Poly, Brian Granger, who's one of the PIs on this research project of Project Jupyter, he teaches a data science class. And although it's an undergraduate class, the content is really graduate level. And the students learn much more in a 10-week term than they would have learned without the notebooks. They just get up the learning curve that much quicker. Many of the students come in with no knowledge of Python, and after running through Jake Vanderplas's whirlwind tour of Python, they pretty much know enough to get going, and they pick it up more and more as they go along. There is a reference deployment online on GitHub under the JupyterHub organization for how to deploy using Ansible JupyterHub for your own projects. And then these are some screenshots of actually JupyterHub running. The ones on the bottom are what you as an administrator would see or as an instructor would see. And the one on top is actually Brian teaching his students using JupyterLab, which will be the next generation of notebooks. It's currently in alpha. And it has some cool functionality in that you could have video, you could have documentation all up in a multi-paned window. Or, for those of you that like simple, clean, not complex like me, you can have just the old one linear notebook where things just make sense. So you really can tailor it to what works in, and I do use both. We have been incredibly fortunate to have some folks funding our research project. We got $6 million a couple years ago from the Helmsley, Gordon, Betty Moore Foundation and Sloan Foundation, which has enabled us to really accelerate the pace of both the Jupyter Notebook, JupyterLab, and JupyterHub, and we are very grateful for them for that. Applying knowledge, probably the best example I have seen, and there are definitely other ones out there, University of Illinois does a fabulous job as well, is UC Berkeley has a very extensive data science program. Data 8 is a course that many, if not all, students, undergrads, but a lot. Several, 600, 700, so cool. And the goal is eventually to have all students that come through the university take it. And what's interesting is it's taught from the perspective of applying it to multiple disciplines. So whether you're doing psychology research or scientific research or anthropology, there's ways to integrate this data science. One of the great things that have come out of this is we now have a guide that will show you how to deploy using Kubernetes and manage it, and it is far simpler than anything that we've done before. And I would encourage you to try it. You basically set up a Google Cloud instance and then run the Kubernetes. And we also are working on Azure and Amazon as well. So as it gets rolled out. JupyterLab we just talked about a little bit. So it's going to allow you to apply language and knowledge in different ways. And since we're getting close on time, some of the next steps. We do have a mailing list, Jupyter in Education community. Highly encourage everybody in here to join it. It's a fairly low traffic, but really good content mailing list. You'll get to hear what people are doing. Definitely, I encourage you to try the no installation needed solutions like TempNB or NB Viewer, Binder. Actually, Microsoft has some wonderful notebooks that you can run there, as does Continuum. Try using TempNB for a workshop, whether it's a user group, small group, 5 friends, you know, being super nerdy, learning something new, whatever. Then try and offer a course using JupyterHub. There's some great models of information, as Andrew pointed out, and then scale your curriculum to other courses. Some of the resources that you may find useful down the road are these. And that's a little plug for JupyterHub. But if I leave you with nothing else, I want to encourage you to try Jupyter, to try teaching with it, see how students react to it. Give us feedback if something's not working the way you would like it to work. And it opens doors not just here within our little Python family, but really much farther beyond that. And we really have a chance to solve some very complex multidiscipline problems using JupyterHub and letting people communicate across disciplines a lot easier. So thank you. Are there any questions? Do we have time for questions? No. Yes. We're running behind. Okay, so she let me finish my presentation, so that's a positive. Give it up for Jess. Thank you, everybody.
So, I believe that Carol will at least be around for the rest of the day. Like she said, she would offer an open space to people who are interested in learning all the things. So now we have Al Swiger. He's going to talk
Oh!
about Tortuga.py. So teaching Python
Sorry.
outside
I stole your time.
No problem. Mine's actually kind of.
something that I know
Okay.
I don't think about doing as much as I could.
Way to go, buddy.
And we are running a little behind, so I'm going to be very strict with the question situation, so that way that you guys can get to the beverage situation. Not those.
Oh, like this. Okay.
That's later. Yes. Yes.
When the venue opens, okay.
Yeah.
You kind of bend it and shape it.
Sorry.
Yeah. Turn it on so you're hot now. And let's see, you were HDMI? VGA for. Okay. Okay. Just gotta place it in there. It should be okay. Okay.
All right, hello everyone, welcome. Thanks for coming to my talk, especially because the talk going on in the other room looked really great and I kind of wanted to sneak out of this one to watch it. Anyway, hey, my name's Al Swigert. My last name rhymes with Y-Dirt. I'm principally known in the Python community for writing Automate the Boring Stuff with Python. I've also written a few other books as well, all on Python, all for beginners. Those 3 are in particular for kids. I'm also the education director at the Museum of Art and Digital Entertainment, which is a video game museum in Oakland, California. And my talk is, if you can still see it, Tortuga.py, extending Turtle.py beyond English. So Python is famously known for having batteries included. Its standard library contains everything, a whole bunch of different modules, everything that you could ever want, including some things that other programming languages don't really have. Like there is a GUI toolkit called tkinter that comes with Python, and there's an IDE that comes with Python called idle that uses this GUI toolkit. That's really weird. It's really weird for a programming language to come with an editor. But as far as I'm concerned, it's great because as a book writer, I don't have to spend several pages of the first chapter covering how to choose an IDE, how to download it, how to install it, how to configure your environment variables, and then repeat all of those instructions for Windows, Mac, and Linux. And I'm pretty sure it's great for a whole lot of other people as well. If you're a teacher, you don't have to ask the district IT department to give you permissions to install another piece of software for the IDE and then configuring it and then having to install it on 30 different laptops for your classroom. It just works, which is great. And I really think that idle is responsible for a lot of Python's adoption, much more than we probably think it does. So another thing that it comes with is Python comes with a full implementation of Turtle Graphics. You might have done this when you were a kid because Turtle Graphics has been around since the 1960s and 70s, basically. It's the thing where you have an object on the screen called a turtle, and you can program it to move up 100 steps and then turn right 90 degrees and move forward. And behind it, it's drawing colorful lines. So you can just have a few lines of code that create these little spirograph images, but there's a lot more that you can do with it. I started doing some of my own little turtle programs, and I came up with many examples, just many, 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 many different things that you could do. And again, this all comes with Python, just turtle.py. You can just run turtle.py and it's there. And another thing that comes with Python, I actually was using turtle.py for I think a couple of years before I even realized that there's also turtle demo, and you can run this module from the command line just with python-m turtle demo, and it creates a full-blown app that, again, you have an application that comes with your programming language. That's not something any other programming language really does. And it has many examples of different things that you can do along with the source code. Just many, 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 many different examples of things you can do. And this is just great. Turtle.py is a huge bonus to Python. But in a certain sense, turtle.py is sort of already obsolete. If you're going to take a classroom full of school children and introduce them to programming, you're probably going to use something like Scratch, which Scratch itself has its own turtle drawing system. Scratch is this education programming tool from MIT. You have these snap-together blocks that fit together like Lego bricks, and each of the code blocks does a certain little thing. Pretty much every single tool that you see that uses this block sort of block-based user interface has copied Scratch. But anyway, I'm going to get back to Scratch. First, I want to talk about myself. So I'm American, and I'm proud to be an American most of the time. So I grew up in Texas, and I grew up in an English-speaking household. But back in 2013, I decided that it's about time that I see the rest of the not America world. So I spent a month just backpacking through Europe, and it was amazing. Just there's this entire continent of people who don't speak English. I just couldn't conceive of this. It was, I mean, there might be other continents where they don't speak English as well. Even in the UK where they speak English, they still use a L to draw out their dollar sign. Anyway, so I got back and started thinking about software development and the dominance of the English language in software development, and what this means if you're a school kid in another country who wants to learn programming, because programming is challenging enough as it is, and on top of that, you have this language barrier because, the programming language itself is all in English. These are Python's keywords, and this is true of every major programming language, even ones that are developed outside the English-speaking world. Ruby from Japan, Lua from Brazil, Python from the Netherlands. If Guido had decided to use Dutch for Python, then all of these keywords would look like this. And, it just becomes a bunch of symbols that you have to memorize what they mean. But as strange as this looks to you if you only speak English, this is sort of what Python looks like to everyone outside the English-speaking world. So there is internationalization, but this is more of a thing for users of software applications. Internationalization is also called I18N because we're all really busy and we don't have time to type the 18 characters between I and in. You have a string table that has all the text that appears in the user interface along with their translations, and based on your operating system's locale settings, it'll display the correct translation for you. But the source code is still most likely going to be in English. All the function names, all the comments, any third-party libraries that are used are probably all going to be in English. So let's go back to Scratch. Scratch has this really weird feature. On the menu bar, there's a little globe icon, and when you click on that, it opens up all these dozens of different languages. And when you choose one of them, the entire user interface instantly changes. The editor changes, all of the code blocks, which are basically Scratch's keywords, all of that changes. And this is also really weird because normally this isn't standard software development practice, because what you're supposed to do is check what the browser's locale settings are, and then maybe you serve up a different web page or something like that. Scratch reinvents the language settings in its own application. But if you think about this as Scratch is an educational tool aimed at primarily a younger audience, and you might not want kids to start crawling around through all the browser settings to change the language around. So this makes a lot of sense, even though it's not at all what you would typically have in ordinary software. So I thought, hey, we could do this with turtle.py. So there was a group of us and I who essentially just copied turtle.py and then added all of the Spanish translations for the function names and method names and class names, everything in the language. And that way, your turtle program that looks like this can be typed as this. So all the Python keywords are still in English because they have to be. Like, literally, you have to use English keywords, otherwise the Python interpreter software won't work. But this does remove a substantial language barrier for all of the different function names and even the strings inside that you pass to these functions and that are returned from these functions, you can change. And it's not really that much code, and I just went through it. I hopefully have the Spanish mostly correct. But this is all done. You can actually check this out right now. Just run pip install Tortuga, and it works exactly like turtle.py does, except, of course, with Spanish names instead. So it's still open to revision, so I have this GitHub page for it. But at the same time, this really isn't enough. I mean, the great thing about idle is that it comes with Python. There's zero configuration and setup that you have to do. It would be really great if you didn't have to run go to PyPI to install this module on all 30 laptops in your classroom, but rather if this was actually just part of Python. So that's the end goal for Tortuga.py, is to actually run through, get it in shape so that it can actually be added to the Python standard library as a part of Turtle. If you do a diff of the image of the source for Tortuga.py, it's essentially turtle.py with a bunch of stuff added onto it. So there's a string table with all the Spanish identifiers and function names. This is basically just a Python dictionary. There's a bunch of aliases that just get added to the function names, and altogether it's about 4 kilobytes extra added to the source code. So this means that we could add dozens of different languages and not really blow up the code base of Python that much. Ideally, it'd just be great if you could say import turtle and then run one function to switch the language. This wouldn't be the case for everything in the entire Python standard library. We could just have this as part of turtle.py, which, if you're running a course that isn't necessarily a deep dive into programming, but just, a small elective unit where kids won't see anything outside of turtle.py when they're just programming, this could be a huge benefit without that much work. Oh yeah, just as a small example, here's what some of the code looks like. I literally just have a Python dictionary that I've added to turtle.py, along with a little for loop that just uses locals to add all of these function names, in addition to the English names as well. The rest of this is on GitHub. So yeah, it's not that much work, but it's something that I really can't do on my own, so it really involves you, or you, to help me out, because remember, I'm just a dumb American with a QWERTY keyboard, and I don't even know if the position function should have an accent character or not, which I don't know which is normal for if you're a programmer in Spanish. And there's lots of things I don't know. So this is something where if it's going to be added to the Python standard library, it needs to be done right, and if it's going to be done right, it really needs a lot more eyeballs and brains on it. So what I do have is a spreadsheet of all the identifiers, and then we can just sort of fill this in. But there's a lot more work than that, and it also requires several different skill sets. I mean, one, it requires people with language skills to do the actual translations and verify the translations. It requires programming skills to add the code. And this is not a if you build it, they will come sort of thing. People have to find out about, oh, turtle.py now supports all these foreign languages. So I'd like to get the ball rolling with a simple Python turtle.py tutorial, which can easily be translated to other languages as well. And also, yeah, just it requires a lot of outreach and community evangelizing just to reach out to other instructors outside the English-speaking world. And also, it requires people who are familiar with the process and politics of adding something to Python this substantial. Fortunately, there's a great time to do all of this. If you're going to be hanging out for the sprints, I'll be here for the first couple of days. And afterwards, we can just all work remotely on this. Anyway, but when I say you, I don't mean just you providing free labor and your time for my project here. I also want you to just sort of take away this mentality in your own works. If you maintain open source projects, think about how you can expand your audience beyond people who, besides people who have English as their first language. So if you create tutorials, are you creating, think about, hey, who could I find that could take this existing tutorial material or some blog post and translate it to other languages? Or the same thing with documentation. There's a lot of things that I realized I don't know, in a lot of tutorials and other open source projects that I've done, where I tend to use a lot of idioms, like in the comments, or things that don't really translate all that well. And just thinking about it now, I realize, oh, you know, I'm making all these sort of inside jokes or things like that, but if people download, PyAutoGUI is one of my open source projects. If people download that and start looking through the source code, if English isn't your first language, how easy is it for you to understand what exactly is going on? I mean, people can probably figure out eventually, but if you just use very plain language, you can make that as accessible as possible. And that's really what this is about, is taking Python and just getting rid of these barriers to entry and making it more accessible to others. So if this is something that interests you, or you just want to even check up on it, feel free to get in touch with me, or I'll be around at the conference and here at the Education Summit. But yeah, that's basically what this is just helping out the next generation of Python developers, even the ones, even if you're outside of the English-speaking world. But thank you very much. Do we have time for questions? Yes. Perfect. Yeah. Yeah, sure.
Does it work?
Oh, do we have the mics on?
I don't know. Does it? Okay, I will just.
Well, you can ask and I'll just repeat it into the mic.
Have a look at Transifex. I think it's called for translation. It's a website that is made better than Excel. I'm not going to say anything more Excel.
Transfx.
Wait, oh.
So actually, so the question is, how do you translate doc strings? And if you look at turtle.py, I only noticed this a little while ago. There's actually the foundation for, there's a function in there that's like read doc strings and write doc strings. And so the foundation, the authors of turtle.py originally laid out this sort of foundation for code that could easily import new doc strings and just generate different documentation. So that's something that I need to take a little bit more, look at a little bit more closely. That probably is going to require just a lot of making use of Python's introspection features, which is sort of what I did with the method and class names as well.
My last point is that I didn't learn programming in English,
Mhm.
and I think that it's a personal thing that I felt. Trying to push the translation of a language too far becomes hard when you, because at some point you will have to mix and match some libraries like requests that are in English and
Mhm.
won't be completely translated. And the mental load in writing a program in two languages where you have English mixed with other languages is way higher than learning English and completely switching to English. And I used to be someone who was strongly pushing for internalization of everything. And now I have switched my OS completely to English. I have switched everything to English because it's really a different mental load, and I really appreciate that things where you learn programming are frustrating, but I would be careful with more core tools because I think in the long term it might be a disservice, not the documentation but the tool themselves, the name of the function, it might be a disservice to
Oh yeah. So the question was sort of pointing out how it could just, actually having to deal with two different languages might be more of a headache than just dealing with English alone. So I wanted to say that I very much agree, and I don't think that it's best to change the entirety of Python or even a lot of tools over to this. But going back to the example with Scratch, where you can change its user interface, I think turtle.py sort of has this same special case where a lot of like just for a small elective unit where you have some kids do programming, even if they're not, or I guess in particular, if they're not going to move on to become software developers or move on to start programming in Python elsewhere, if all they're taking a look at is just a unit on turtle.py, this could be something that's very helpful, having the function names already translated for them. And of course, if you start having to mix and match turtle.py with other code, that could become a headache. But a lot of the times for the turtle tutorials that I've seen online, it's mostly just been sticking to the Python keywords and then the functions that are in turtle.py, as opposed to like importing other third-party libraries in. So I agree, like it's very weird for Scratch to have this feature that changes the entire language, but it does have a very particular use case where this is beneficial. And so I think the same thing would apply to turtle.py as well. Any other questions? Oh, all right, well, thank you very much.
Check, check. 1, 2, 2, 2, 2. Check, hey, hey. Well, you see, Python is, I'm taking this all mainframe content. Mainframes and run. How to make it easy. It turns out, it turns out that's where the money is. Okay, and so I'm trying to develop, and they don't really do graphics, so it's a really great environment for that. And so I'm just kind of stuck. I'm finding it's a really fruitful area because the idea is just like Python, you're in a language environment. You could do the same thing in Python. You could write big long strings in Python. Well, you couldn't because of the rules. You can literally cut and paste sections of code into Python, and I do it all the time. And so I'm good with that.
So now we can.
Really fascinating problem translating. And I got to thinking, okay, does your translate module actually, when it reads in the doc string and then you translate it and it writes the doc string back out into the code?
Were you talking about the...
Yeah, for Tortuga?
Oh, yeah. No, I mean, what we really did was took the existing turtle.py and I had some... Probably just punch it up real quick.
Oh, no, just
Oh,
explain
okay.
it better.
So I add just one Python dictionary that's just this massive dictionary that has all the function names and everything, and all the other English names, and then the translation keys. And then I use the locals function to basically just add. Originally, I was thinking like I'll just use a val and have like Spanish name equals English names for all the
Okay.
functions.
But that, oddly enough, using a dictionary has a certain sense to it,
Yeah, I mean,
It is a
it's
dictionary.
a one-to-one mapping for everything. So I mean, all the English, technically in Tortuga, there's all the English names for everything are still there. Really,
It's just,
yeah, it's sort of like I'm adding a whole bunch of.
you're patched it, yeah, okay.
And I wanted to make it so that it's easy to do this once you have. Like I didn't just go through the source
I
file.
mean, what I flashed on was the idea of, quote, quote, E, unquote, quote, E, is the English doc string. Quote, quote, S, quote, quote, you see where I'm going? That you would
just like
re-delimit it.
that one.
Yeah. You see what I'm saying? Because I'm a big believer in perverting delimiters. It's a hobby. Everybody has it. And so, the idea of, even if you want to, because it's quote, 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 right? So go quote, 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 E, and you're going to get an English document, right? And then you could terminate it with either just a quote, 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 or a quote, 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 E, the best form. And then quote, 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 S. So now suddenly you have this ability to, so you can add, Italian or Chinese or something. Quote, 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 I.
I mean,
I don't know.
Oh, yeah. I mean, I basically was trying to think of once I have these created.
You could suggest this to, and you could slug us.
Yeah, and also like, one guy did a huge point out. At a certain point, adding all of these different languages,
Yeah.
you don't want to do this for everything. Like, it does make
It
sense
needs to
that
be the tip of the iceberg. Or not.
I do have some sort of like really weird idea of like, I don't know, what if we could come up with translation, like string tables for translation
No, I was,
source code.
I was flashing on the idea of building a visual bash module that stripped out the comments, fed them to Google Translate.
Oh, right, yeah. I tried that.
Oh,
and
okay, it was ugly.
it doesn't work at all.
I didn't think
Like I fed, I think I tried to do like the Russian translation, so somehow I got like Bengal character is out.
No,
or like,
Where is so funny?
from England.
Then how do you know it's correct or not?
Yeah, I need to find.
I had a correspondence with this I wanted to have an Android ready for the car, I wanted for my car, and by God, I was going to really. Okay, and so I got a hold of the XDA people, and we were corresponding back and forth. English is perfect. They were feeding everything through
whether it actually captures the same semantic meaning is.
What I'm saying is, they might just do it, because it was like a couple of years ago, do it again.
Oh, yeah, it actually was a couple of years ago.
But you have no idea, I was like, gobsmacked. This is fairly idiomatic and controlling.
Yeah. Yeah. For the Spanish, yeah. Yeah, Google is.
Yeah. Well, thanks, I really love you.
Oh yeah, no, thanks a lot. I have this fear that the robots will take over, but then actually it turns out things are better when the robots are controlling all of us.
They probably already have.
Are you implying that I'm a robot? Because that is ridiculous.
Well, are you employing,
That is
that,
a
yes,
huge
that is
sounds like-
ridiculous, that is for people.
Probably not better.
Cogito iRobot, I don't know.
And so it goes and makes a couple of modules, so you can say import module in this case. In this case, capital class.
I mean, just so I didn't include the namespace of Python. It's like, oh, we'll just put all of this in Turtle.
Well, what you could say is you could say turtle dot primary, and then that would go set the top of the namespace, and would it have particular or whatever it is on the other one.
Yeah, so wait, so class has this?
Yeah, this is a pretty well known one.
Cool. What's the feature? Like, what would I do with this trying to do class?
So I can show you the exact file right now if you want.
I mean, oh, so it doesn't do this for like translating.
No.
forward,
It
just
does it for
to
this
generate
module called workset.
Oh, okay.
So
Oh, yeah, okay, I've heard of that.
it puts workset into the top of the namespace, so that it can use it on other places. And it also modifies it. So it has features that it exposes for setup, and then it strips them from the top of the module. So it can't use separate the setup.
Like you could run the turtle, and then it wouldn't show you like this function and
Triple quote for English, triple quote, that's good.
So I think it.
And I realized I could walk out down the hall there and go right there.
Almost.
So the pattern I was thinking.
I'm plugged in here, but I'm not sure if that needs to be adjusted in any way.
Yeah, we just do that.
There we go.
We should reset.
And do I have one screen or two screens?
You can have two if you want.
That would be delightful. How do I do that?
Go ahead and unplug for me one more. Oh yeah, that's all I can do. Unplug it, plug it back in real fast. Not real fast, but, you know, normal speed. And then let's give it a second for it to click over. Still. There we go. And so just to make sure, let's just go ahead and start the presentation now.
Doke. Oops. Let me see if I can. There we go.
And so let's back out of here really quick, and let's go to your system preferences.
Yeah, you should.
The Apple icon. Okay, yeah, to display. And let's go to arrangement. Click unmirror to unmirror.
Awesome.
And then now you should have two screens. So this will be
Thank you
what's
very
on
much.
the screen, so you don't have to actually go look when you
Oh, this is what's actually.
through the projector. Yeah. Oh no. You can stay over here.
Okay.
And then hit start.
Oh, you encountered this.
And so this side will be your notes and your next slide, and over here is what. This is just so you can visually see
Oh.
what's coming through the projector. So you don't call it a confidence monitor, just so you know what the people are saying as you're talking.
Is there any way to just have it presenting over here while I have, because I have a separate, or maybe I can just copy my notes from here into that.
If you have time for that, otherwise,
What would be the fastest way for me to be able to see this while I present?
let's go back over to start the presentation again.
Sure.
And let's see. No.
I don't see any way to edit this.
Yeah, you normally do, you don't edit here. You would do it when you build your slides, but since we haven't done that,
Oh, here we go. Click to add notes.
yeah.
Well, that's gross, but let's
Yeah.
see what happens when we actually, maybe it doesn't look so gross in the program.
Yeah, it'll just all be, yeah, so now it's all on your first slide only. When you click to the next slide, it'll show your next set of notes.
Oh, that's awful. Well, we don't want that. Well, you know what? Not the end of the world.
Okay, yeah, I've never really had to just run the presentation on one screen before.
Get rid of all these. There we go. Beautiful. All right. Okay. It, doesn't really matter that terribly much.
Okay.
This is more for me anyway.
Gotcha.
I have enough hints in here, I think, to get by.
Okay, good.
So, yeah.
And then for this, if you just want to put that on sort of like a pair of glasses, but from behind.
Excellent.
When you're ready, go ahead and just hit the switch.
Okay.
And you'll be ready to go.
Cool beans. Thank you.
Yeah, you bet.
All right. Hey, hey. Oh, yeah.
All right, we are going to get started again. So if everybody can just find themselves a cozy seat, we'll get going. And for this talk, Dan Posmenter, who gave the earlier lightning talk about philosophy, is going to now go talk about teaching practical Python. So, Dan, thank you very much.
Cool. All right, thank you. Ooh, that's pleasantly loud from this side. I like it. It's like being enveloped in a warm auditory hug. So, thank you all for being here and taking time out of independent projects, work, school, and etc. So to get things started, my name is Dan Posmanter, and a bit about me and why I'm presenting. I am a programmer by trade and a teacher by passion/accident. I got started teaching philosophy at the secondary school level and moved on to teaching it to teachers at the elementary school level. And I also teach improv comedy. But I also do a fair bit of programming and teaching programming. Teaching programming a little bit at the secondary school level while I was in college, but for the most part, teaching it to other employees, especially more junior employees, but occasionally employees who are more senior than me, which is always a weird, wonderful experience. But what I've noticed in doing this is that there are certain gaps. And another way to get the same bit of knowledge is to simply look at your own experiences. How many people here in the room are professional programmers? Cool, great. When you first got started, your first job, and you went out of whatever your introduction to programming was into the workforce, how many of you felt overwhelmed? Ooh, okay, less, but still significant. I was completely overwhelmed. The first few weeks at my first job out of college as a programmer was a startup with about 13 people. And the way they did business was basically, oh, that framework that you want us to know, Shark? Yeah, we got people who know that. Okay, cool. Get off the phone. All right, guys, we need to learn Shark. We have 24 hours. So, so that was a bit of a panic attack. And that is really the goal and the motivation for this talk, is reducing panic attacks. This isn't about how to create the perfect worker bee. This isn't about programmers becoming the new blue-collar job. I don't know if any of you have read that article. And it isn't about the laudatory goal of expanding programming to everyone. This is simply about, all right, in the course of teaching programmers, can we give students an experience that's a little bit closer to what you're going to run into in the professional world, so that when you do make that jump, it's not big and scary, it's comfortable and familiar. Make sense? Maybe? Excellent. So, oh, I kind of already went over that. So the biggest jump for me in moving from programming in an academic setting, college courses or AP Computer Science or whatever the case may be, is moving into how you think about problems. And this is actually a really good measure for looking at the difference between a more junior developer and a more senior developer. So for example, thinking ahead. A more junior developer might think, oh, well, I'm just going to solve this particular problem in front of me. As you start getting more and more experienced, very quickly you start asking questions like, well, what problem am I going to have to solve next? Has this problem been solved before? So basically, to put this in another context, if you're in a classroom and you're learning about something very basic like what a class is and object-oriented programming, it doesn't necessarily lend itself as well to that sort of shift in perspective. However, as soon as you start making something practical, suddenly it does. And a good way to think about this is through the use of, I guess, more project-oriented programming. So raise your hands, how many people in here teach? Cool, great. When you teach, how many of you assign a maybe mildly ambitious project, like you're going to make a web server? Okay, cool. So that's one of the things that I think would be great to change. And it's tough because, especially at the secondary school level, you're already competing against so much. You're competing against time constraints, teaching to the test, curriculum. Just within a computer science curriculum, you have to get through, okay, well, let's say you're learning it in Python or Java or whatever, the specific syntax of a language, the basics of programming, and how to really think like a programmer. So it's hard to make that jump. But to kind of sweeten the deal, there's another benefit to making that jump, aside from it basically providing an excellent vehicle for teaching perspective. And that's that programming is fun. How many people enjoy programming? Cool. Why? Anyone? You like to solve problems. Anyone else? It's hard. What? Sorry, I heard something from over there. Cool. That's the same thing. And it's fun. Yeah, it's a big problem, or it's a practical problem, or it's a useful problem. Some of the first programs I wrote were, looking back on them, pretty dumb, but I wrote a program in C++ to search the state legislature for interesting bills.
One single comment line.
It's true, there were no comments. But what this has in common is it's exciting because you're doing something that feels like it has value and that isn't immediately within reach. It's like that exciting, and I forget the name of the researchers who proposed it, but this idea that anything that's too easy or too hard misses that sweet spot. That's exciting, and that's instructive. So we can follow that. So if you give something that's more ambitious, so for example, we're going to make a website to conduct polls. Anyone who's worked with Django has looked through the getting started, and a polling application is a very common first application for someone diving into a web server as like a kind of a vaguely leveled up hello world. But it's something you can use right away, and it's something that you can start asking these perspective questions. So has someone solved a problem like this before? What do you do then? How many of you who teach talk to your students about finding other people's work and learning from it? Ooh, good. All right, never mind, that's done. Congratulations, we're set. How many, oh, sorry, what? Leveraging. Oh, that's diplomatic. I like it. I'm going to leverage that. How many of you talk about this idea? So I think I should go into future needs and future requests a bit, because that's somewhat deliberately vaguely worded, but a very common thing in the programming world, the professional programming world, which is, let's say you're working for a startup and you have a new product coming down the line. It's never just that new product. It's that new product and, okay, actually we're going to do some user research and it turns out we need to pivot and actually go in this direction. And also the CEO sees a business opportunity, so if we can throw in these 3 extra features, that's going to be a thing. And you start doing that enough and you start realizing, okay, well there's a pattern to this. And there's basically a couple ways to react to that pattern. But before I get to that, how many people cover something of that nature when you teach? 1. Cool. So when you're teaching programming, if you have a project that you give your students, do you change what you're asking? Do you add things in?
Scope creep.
Yes. Do you teach scope creep? Thank you. So so in the interest of making it more real, that's one thing that commonly comes up. Another thing that comes up is just thinking about it from another point of view. So one useful frame of mind, and this is really, I mean, we can steal from every discipline out there. So for anyone with a theater background or an improv background, if you have this idea of being a different character and approaching the same situation, a character who reacts to everything in a really joyous way is going to see an insurmountable obstacle as another wonderful opportunity. Looking at bugs, looking at things that are breaking, as someone whose job is to break things, suddenly it becomes exciting. Or looking at things as like a white hat hacker. So one of the things I used to love to do when I was in high school in class was I'd break other people's programs. And I'd invite people to break mine. How many people, when you teach, do something of that nature? Cool. A little bit more hesitant, but it's still there. Oh, yeah, no, sure. Terrible. Another interesting frame of mind to use is thinking about things as if it was your business. So this is something I do all the time when I work for a startup. And the question is, how can you start doing this in the classroom? So this goes back to this idea of having projects. So one thing I'd like to propose, and again, this is not the most well-organized or pretty presentation that you'll see today at the conference, but I want to think about this as starting a conversation about ways to change how we think about education and programming. So my guess is, if I were to ask how many people in the room consider, well, how many people have considered a class as a company? 2. Interesting. Maybe, but yes. How so?
How much detail do you want me to go into?
Elevator pitch it.
So what I have done is I did this with a music class, and I'm doing it with my summer coding class. Basically, we had a recording company, and so they had to do all the things you have to do if you were to be an artist, pitch a song, write the song, record the song, do marketing for the song, put out the whole thing, and we
Cool. So it's not difficult to imagine doing this in a programming setting, where you start a semester with, all right, well, we're going to be using programming. We're going to be using Python specifically. What would you guys like to do? For the next semester, we're going to work on some project. What does everyone think is interesting? And maybe you come in with a list of particular topics and they pick from among it, or maybe you really throw caution to the wind and you say, all right, students, you're in charge. We can do whatever. We can build a Twitter competitor. We can build an Instagram competitor. We can build Snapchat that only works for kids at this school. And as soon as you have that, well, now you have a business. And at that point, you can start inviting the students to think of themselves as occupying every potential role in that business, and that gives you an opportunity to prepare them for encountering that in the business world. So for example, all right, everyone today, we're going to be the CEO. Came up with an idea for, and let's say we're doing this right now. We have our semester, we're all learning together. What would people like to do? Hmm? Sure.
I've just been saving this up. Jessica, you know that project you're talking about takes a lot of audacity.
Oh, God. All right. No, it's okay. No. And programming puns are delightful. God, since 2003. Why do you ask?
The project that my group is working on is called Techno.
Okay.
No, that's the meth lab is working on Techno.
One of the things.
Computer lab in a Methodist church. Give me a break.
So I think you're talking about needing to make modular, reusable code so that people can not waste time and have to reinvent the wheel every time they're working on a project. Is that the type of thing that you're trying to teach people?
Eventually. I'm just saying, well, I guess for this particular part, I'm suggesting that one way to teach coming at the sort of problems you solve as a software developer is to come at it from different angles rather than just a software developer. And one easy frame for doing that is to use projects as opposed to any other particular way of doing it. Yeah. Well, well, why don't we skip to that then? We can always come back to this. This is a little bit controversial. So, right, common problems. So there was a fascinating study on the unhappiness of software developers, and bad code quality and practices were actually, I think it was number 3 in terms of prevalence. And the reason I want to draw attention to these things, so yes, spaghetti code, poorly documented code, not being familiar with what a unit test is versus an integration test. These are problems that, transitioning from the academic world to the professional world, students are likely to run into. The bigger problems are just what to do when you get stuck and the pressure of time. But I think all of these are actually delightful because each one is an opportunity. So for example, time pressure. How many of you have given your students an unreasonable amount of time to get something done? Yes. What did you do?
I gave people 1 week for a scavenger hunt.
How'd that go?
About 40% of the class finished the hunt, and 40% gave up afterwards.
Interesting. Did you discuss it afterwards and gain any particular insights from the group who finished?
The group who finished felt really
Mm.
but the group who finished felt like they took the challenge in stride. And the first person to finish the scavenger also like won a Python plushie that I thought
Oh.
they felt good about that. The group who did not finish also articulated like feeling like there was a growth moment in learning that it was okay to not finish a school assignment. Like they said this was the first computer science assignment they just didn't even get halfway through. But it's okay because they were doing well in the
Yeah, certainly. So what's exciting about that is, to me anyway, the first thing that jumped out, because there's multiple exciting things about that, is that's an extremely common thing. So earlier I asked how many people in here are professional programmers. How many of you have been in a situation where the reason something couldn't be done in a certain period of time is because the requirements were not going to be in place? So for example, you're working with graphic designers, that sort of thing, and you know whatever assets you need aren't going to be ready, and instead of having 3 months to code, well, really you're going to have 1 month. Yes? Cool. Yeah. So for myself, when I run into that problem, one strategy I've used is coding ahead, or rather, creating scaffolding. So for example, I know, well, we're building this sort of system, so we're going to need something that handles this influx of data. So you can start, great. So that becomes an exercise for students. And you can start it off by, perplexing them first with an unreasonable demand, and then afterwards seeing if any of them arrived at that conclusion on their own, which can be delightful. It depends on how much time you have to work with. I'm a fan of doing that when you have the time, because the conclusion that a student arrives at on their own is a conclusion that they feel they own. But if not, you can jump in and discuss that as a potential strategy, and you can start using that in the classroom. Maybe? Sure. I'm sorry, I've run through time a little bit faster than I expected.
Just getting to your point, one, students are different than the way they were before.
Sure.
Two, group projects are great. I used to struggle with doing them. Half the students at their first cousins actually solve the problem. The rest of the students typically sign up to work with the guys that had the first cousins to do the work for them. Now that doesn't happen, I grant you, at MIT or my own alma mater, Johns Hopkins, and places like that. But it happens, in fact, it probably does now. Things are different, and we as educators need to come up with a better way of teaching than simply applying tried and true solutions that worked for us, because they don't anymore.
Okay. My counterpoint to that is that it seems like what you're talking about is a difficulty with group projects and discipline with the students, rather than necessarily a problem-solving strategy.
No, it's all related. They don't
Okay.
solve problems. If they can't solve problems, then you can't be a programmer. You can't write the
Well, yes, I agree. Which is one reason. Yes, I think at the core of it, and I want to get to the last bit, but I don't think I'm going to have time. But the core of it is no. Thank you. At its core, programming and math and philosophy are really teaching the same thing: the ability to reason and the ability to problem solve. And it's difficult with that in the U.S. because not every educational environment, state by state, is as amenable to that as it might be. And there's a lot of different pressures in terms of putting that into the schools. And when it comes down to it, the essence of this talk is supposed to be about creating opportunities for students to go into the workforce feeling more prepared. But really, the most important thing is is creating students who are just going to be strong people in society. I guess Sorry, I'm kind of close to running out of time with this, but no. Well, that's the thing. And I guess the thing that would be one exciting takeaway of this is to, in as many ways as possible, if you can treat a classroom more like a job, which sounds drab and disgusting and horrible, but I mean from the exciting, like you're creating something, you have agency in choosing what you're doing and how, then that creates opportunities for students to work together and to plan and to take ownership of what they're doing. And the other aspect of it is simply that as educators, everyone in this room and myself, there's this responsibility of creating students who aren't going to be sucked into the black holes of the technology industry. And by that I simply mean as much as we cultivate a love of learning and programming in Python and all of that, that we also make sure to cultivate and create room for outside interests. And just a really quick question, because I am almost out of time. How many people have had who are professional programmers, have had a job interview where the idea that they didn't spend their free time working on open source was viewed as a detriment? Just me? Ooh, okay. That's the New York startup community, I guess. All right. Cool. I wish I could. Am I pretty much out of time? Oh, I've got 2 minutes. Oh, thank you. Oh, well, then I guess really quickly, everything I talked about applies really well to corporate training. So over the past 12 years, I've done a lot of corporate training internally and externally. And yeah, the only things I'd add to that is that in addition, something like code review. So how many people, if you're a professional programmer, institute group code review within your companies? Cool. So that's an opportunity to take a step back and invest a little bit of extra time and teach various programming principles. But yeah. All right. Thanks for listening. I'd like to use the rest of the time for questions.
Hey, okay. Yeah, so often when students that I'm teaching have some sort of problem, they come to me and usually they say something like, my program doesn't work, or they ask some question that, like, part of me really wants to say, this is something that you can Google or look up on Stack Overflow, and I sort of want to guide them to that, but I don't want to just instantly shut them down with like, oh, just read the manual or give that type of response. I don't know, do you know of any sort of wording or some way that you can sort of convey that this is a question that you can answer for yourself by looking up answers online? Just, are there any sort of constructive ways to guide students to that?
Yes, absolutely. Oh, is this? Okay. Hi. Yes, absolutely. There's a couple ways to do it, but basically it comes down to conveying that there's multiple ways to arrive at the answer to a question, and that it's a question of the utility and the time and the resources available. So, can you ask anyone else in the class to help you? Can you look up any documentation? Is there no documentation? Do you have access to the source code? Do you understand the source code? How are you phrasing the question? The way you Google something determines whether or not you're able to find what's going on, especially if it's a sufficiently difficult or rare question. And this idea of conveying that a lot of being a programmer is being good at finding the answers to questions, I think makes it exciting and makes it not, oh no, I'm stuck again. It's, oh, okay, I'm stuck. How am I going to find the answer this time?
So, time for a question? No? Okay.
No, no,
But thank you very much.
Thank you.
And our final talk for today will be Sam Hartman, talking with us about breaking bad habits and the usefulness of feedback, specifically style feedback in our code.
How much can I move around the frame? Like walking.
Oh, no, you'll be able to walk around completely. He had accidentally turned it off. Switch on. It happens, yeah. It gets really easy to fidget with it. So, yeah, I'm going to turn it on, and now you're on.
Come on.
Yeah, and just, try not to play with it.
All right.
Did you want, do you have notes that we need to see?
Yeah.
Yeah, we can.
You want to open up displays? Okay. All right, hello everybody. I can't hear any of the loudness that other speakers are describing. Can everyone hear me? All right? Okay, fantastic. So I know in the last talk, right before we switched into this unconference session, so I want this to be an exciting way to wrap up what's been a fantastic education summit. Like Jess said, we're really focusing on breaking bad habits here, and in particular, how style feedback is this unreasonably effective tool to help students and colleagues start to think with Python. So this is me. I always use my black and white photo because I think it makes me look older. I am a student of computer science, graduating in a couple of years, so hopefully I'll be out into the real world facing all of these real world work challenges. I'm so excited for time pressure and changing goalposts. And I'm an instructor for a class at Stanford. It's CS41 Happy Code, but hap.py, which is a introductory course on really the fundamentals of Python. And I think a lot of times when we learn Python in the real world, we learn it through like this sort of scrapbook collection of snippets from Stack Overflow. People who come to PyCon usually have a deeper understanding of the language, but the students we teach may not necessarily understand the principles and the zen of Python that underlies its philosophy. I actually kind of fell into teaching in an unusual way. I hadn't done a ton of Python, and I needed it as a prereq for a later class. So I looked in the course catalog and said, which class teaches Python? Like real understanding of what it means to think with Python, to write programs in Python. And I couldn't find one because one just didn't exist. And then through a series of administrative hoops, we went building this class and building curriculum. So now there is this utility to sort of see Python itself as a language, as a standalone thing to study, not just what it can be used for, but the decisions that underlie the language itself. I'm going to make some assumptions about what everyone here is doing. This is the Education Summit, so I'm hoping in some way everyone here is an educator, whether that is to students or to colleagues, and that you in some meaningful way give style feedback on code. This is to say style feedback is supposed to encompass things that are not just functionality, not just did you finish what we asked you to do, but did you do it in a stylistically pleasing and elegant way. I'm also going to assume that the students and colleagues that you've seen may have worked with other languages before. I'm using Java and C as like a placeholder for languages that aren't Python. This is to say sometimes it'll be MATLAB, sometimes it'll be R, it could be other modern programming languages. But if you have people who are coming to Python for the first time from a language that bases itself in such different ideas than the ones that Python takes, there are a lot of challenges. And I'm also going to assume that people are just a little tired and a little sleepy. So if it's ever the case, you just need to stand up and stretch a little bit, move around, feel free to do that. I won't be distracted at all. What we're talking about today is really the arc of what style looks like in Python. There are a couple of classic idiomatic faux pas that I'll show, and then I want to transition into a sort of active framework for how to address these when they come up in code reviews that you're doing or in submitted assignments that you need to review for your students. I think just at a very, very high level, this is about understanding why style feedback can be used to
teach people what it means to think with Python. People who come to my class in particular do Java and C++ as the introductory Stanford classes beforehand. And Java being the very first programming language a lot of students are exposed to, they come into these problems that we offer with an object-oriented background. The idea that every problem in the world is best solved if you think of objects as your primary entity. Things have state, they act on each other, and that's the only thing that really matters in the world. As you know, Python doesn't assume that that's our only solution. So this is sort of the background motivation for this talk. People who come in with this idea, a sort of fixed mindset of where and how you solve problems and how we can pull them into a more multiplied approach in Python. So the big picture, standing back, so you guys can not focus on me and focus on the screen here. It's just the one takeaway. I always say talk should start with a key takeaway. Just your style feedback should intentionally help students think in Python. We're going to avoid doing things like mechanical changes, just say adhering to PEP 8, and instead focusing on mindset shifts that can help people solve problems more Pythonically. As a quick aside, I want to mention that when I say style feedback, I mean something different than a pure code review, where style feedbacks are in a classroom setting, code reviews more in work, and that the style feedback is trying to approach how people think. A code review is more like, did you do what we need to do? Is it successful? Is it in line with the other modules that this larger project has? Style feedback is really supposed to be covering how students are thinking and learning to think about solving problems. This is in a classroom setting. Lastly, I think style feedback should always come with some actionable suggestions, some intentional suggestions that say, this is what you can do to be better, and here is why I'm telling you now. And I think in code reviews, it's always kind of accidental. Things that someone, how many people here have read a code review and said, oh, I should probably change things, but I'm not quite sure what the code reviewer wants? I absolutely do that. So again, it's really on this side. The classic idioms that Python offers are really different than the ones that come up in other languages. So the biggest one of all, I think, the biggest classic example is when people are trying to loop through some sequence. If you're coming from the land of Java, where your loops are like for int I equals 0, I less than some sequence's size, going on and on and on, you might think in Python, I have this tool to generate numbers in order that's range, and I'll get the length of some sequence, and then go and extract the element out of the sequence. Maybe we'll do something with the element afterwards. And this is okay. And when I say okay, I mean it's functional, it gets the job done. But it doesn't really do it right. It's under my section called bad Python because on the other hand, we all know what the good Python is here, with which you can replace it. We can just directly loop over our collections. If we're using a for loop, we can even use iterables. They don't need to be fixed size before, and they don't need to be random accessible. And then we'll get these elements and just do something with them directly. These are the types of style changes I'm talking about today. These are the things where a student may come into your class or into your workspace understanding programming from a Java perspective and think it's perfectly fantastic to use the code on the left. And you can tell them through style feedback that in Python, a better way to approach this problem is to do something like the code on the right. Another classic example is with tuples. Suppose we're writing this greatest common divisor function, a function I just stole from Wikipedia. Using the Euclidean algorithm, as long as b is not 0, we do some sort of swap. And a common way to swap two variables with values that are interdependent in other languages is to use a temporary variable. This pattern may be familiar to people. And that's, again, okay, it gets the job done. But in Python, we have a different approach. Python lets you pack tuples and unpack tuples on the fly. So if you want to, you can articulate that you want to set the value of a and b for new values to whatever the old value of b and the old value of a mod the old value of b was, just with this one line. These sort of stylistic changes that people don't always recognize when they're coming to Python from other places. There's also one of my favorite things to point out in class, named tuple. Python has this idea that readability counts, that explicit's better than implicit. And so I totally stole this example. But for the code on the left-hand side of the screen, we've got a 3 tuple, and then we're trying to access some elements and print out some messages. Does anyone know what the context of the code on the left is? Can anyone guess what it comes from? I know it's a little dark here. It's 170, 0.1, 0.6. And if the element at position 1 is greater than a half, we'll print very bright. If the element at position 2 is greater than a half, we'll print so light. What on earth could this code be doing? Absolutely. It is with intensity of pixels. We have one person in the audience taking a lovely hazard. I think this is to say this is not super clear. You're right. But the context is much clearer if we can annotate our tuples. Name tuple is a stylistic update at the cost of some performance and memory that lets us take some pixel and just make it a color subclass of tuple. This lets us access the saturation and the luminosity. And now if I ask you to read what's on the right-hand side of the screen, it's much clearer what the context of this code is. It was in white. Is there a way I can switch all? Can we turn down the lights at all? Oh, wow. I just said readability counts and no one could even read these slides. So thank you. Thank you for the update. These are always in dark. All my classrooms for some reason have been windowless. So this is a nice switch. I'm a big fan of light colors on black backgrounds. I want to transition away from those examples and just talk about why this actually matters. I have a somewhat controversial worldview that programming paradigms really live in different places. You have your procedural programming paradigms touted by things like C and Pascal, where you really tell it just a sequence of instructions to do. You have declarative programming languages like SQL and Prolog, where you kind of just describe what you want out. You want these columns from this database joined against this or that, and you don't really care what happens behind the scenes. You describe what you want. You also have object-oriented programming languages, like I said, which are a single entity and a bunch of other things around it, and then functional programming languages that try to capture the essence of mathematical functions, outputs that purely depend on inputs with as few side effects as possible. And Python and some other things kind of land in the middle. They give us utilities from all of these different ways of thinking. When I say a Pythonic way of thinking, I think that's a little dangerous because there's no one place where Python says, this is the only way you can possibly think about solving a problem. But because Python draws from so many different paradigms, building on the shoulders of lots of different explorations, it gives us utilities, some of which look a little more functional, some of which look a little more object-oriented. So when we say Pythonic way of thinking, we mean being aware of all of the different approaches to problem solving and using the one that's best for the job. I also have two other sort of controversial but fundamental axioms I'll take here. One is that students have learned biases from other classes they've taken, from their upbringing, from whatever diversity brings into the classroom. Students have underlying biases in how they approach problem solving. Second is that Python has some strong opinions about things that are better, approaches that are more solid or more in principle Python. So as a sort of unnecessary visual that now everyone can see, we've got some students here. We've got 7 different colored students. And they all come from some different place. They all have some different view of how problem solving works. And I claim that the function of style feedback in general is to move people around to somewhere else. In Python, if we're saying the center is a good place to be because it lets us draw on utilities from all of them, maybe people will come a little more close. The blue guy just slid over to the left, a little away from the center, and that's okay. Style feedback isn't saying everyone should think in one particular way, but it is saying, I want to challenge the way you're approaching problem solving, and I want to do that actionably and specifically. So again, the key thing here is how can you make students change or stretch their mental habits, their approach to solving these difficult tasks. And you need to do this in a reasonable way. We've had a lot of sort of mentions of psychology here. It's not sufficient to just say, your solution is wrong, and this is the way to think about it, because students won't own those conclusions. There needs to be a subtle way as educators that we can bring people, in some sense, to see the light of being able to think about these problems in different ways. So I think the best way to actually approach this is with some structured framework for the feedback that we give stylistically. I like to say that there are 3 big pillars of style feedback. 3 categories. When you think about any feedback you give to anyone, they usually, on code, they usually fall into these categories. There's Python code where you want to say, I really wanted you to think like a Python programmer here. Use the Zen of Python. Use these built-ins. There's program design, which are your sort of language agnostic style features, like do you have comments? Do you have any of these other tools? And then there's also the actual mechanics, the PEP8 stuff, your spacing and naming. Do you have one-letter variable names? And so forth. I don't want to make the claim just with more and more unnecessary visuals. If we have our 3 pillars here, style feedback is what sits on top. This is usual style feedback. But if you want to break habits, if you really want to change the way people are thinking in Python, we want to shy away from the Python mechanics side of things, where you can just say run AutoPep8, run some code linter. I want to shy a little away from the program design, things that they will learn about in future or past programming classes, and instead just amp up these Python practices. The way of thinking with Python is really key. When we're talking to people in my class about style feedback, we almost never say something like, your variable names are too short here, too non-descriptive. Or you've got some extra spaces around your parentheses. Just be more consistent with your spacing. And instead we want to focus on trying to allow people to think with this new paradigm, using Python as an ability to reach into different topics. So Pythonic practices, to give some concrete examples, for people who aren't coming from Python, list comprehensions are usually a strange one. Why would you describe the contents of a list in a single line instead of building it up iteratively? Using iterables and generators, thinking about objects that represent streams of data returned one at a time can be a confusing concept. It's a little more familiar to people who are coming from a functional background, but if you're coming from object-oriented land, this can be a really strange idea. Identifying that there are built-in functions and modules for you, that there are third-party wheels, there are third-party packages for you all of the time. Even just like writing custom errors or implementing magic methods to make your own classes behave like other data structures and other built-ins in Python can be really nice ways to exercise the tools that Python gives us to make code read and run more elegantly, where elegantly is viewed subjectively through the Python lens, through the Python Zen. Program design, like I said, is really just this general stuff. It's like your function decomposition and your commenting and everything. I want to make the claim that this is not as essential as the previous slide. Even less essential is our PEP8 compliance. Do I care about your naming and spacing? Yes. Am I confident that you as a programmer can fix your variable names, can refactor, or can change the spacing or indentation? Absolutely. As educators, that's not really our job. A couple of times you can say, hey, this is something you should look at to fix, but there are more valuable things to use with our time. In PEP8, we have our line length sort of controversial thing. If we spend all of our time talking about violations and reasons for line length violations, we miss the forest for the trees. The forest being these Pythonic practices at the start. So just some active strategies, ways you can make sure that the style feedback you're giving adheres to these sort of goals. Your comments should identify a specific weakness. Right? These should be like line comments. These should be function comments. These should not be comments on a whole module. You say, hey, your module was a little hard to understand. You wrote 1,000 lines of code and gave it to me. It was a little hard to understand. It's much better to say on line 753. You want to articulate why it's a weakness in Python or why it's viewed as more complicated than necessary in Python. Very frequently, we have this sort of tendency when we're giving feedback to say, this is not right, you should do it my way. But we don't explain why whatever the student's original idea was in some way problematic. And if it's something that's like submitted code, either for a code review or an assignment, it means that the student at one point thought that was a reasonable approach to take to the problem. And it's really hard as a student as well if someone dismisses my code just saying, what you thought you were doing, not good. You should do it this other way. A way that probably doesn't make as much sense to you. So when you're giving style feedback, you should articulate what about the change you're suggesting is reasonable. And lastly, always offer actionable advice. Even if you say, this loop is bad because it violates this particular standard, this loop is bad because it's really slow, you want your feedback to give actionable advice where you can say, instead replace this with enumerate. Instead replace this with a generator expression. Give examples of places where students or colleagues can take your changes and sort of run through them line by line and resolve all of the conflicts. I also think a really subtle one that's super, super easy for people in technical positions to fall into is just to word them constructively. We want to make sure that students who are learning Python, who are coming to Python from other languages, have a positive experience. So I have a fun rule here. This is the dummy rule. If you can add like dummy or loser or something to the end of your comment, and it still sounds reasonable, the tone is off. Even if you didn't say, like, don't ever say dummy in your feedback. But if it could be placed there, the tone can be interpreted as too harsh. So just as some sample style comments, if recursion isn't the best way to solve this. Okay, but what is a better way to solve this? Why isn't recursion the best way to solve this? And does it even sound reasonable if I would say, recursion isn't the best way to solve this, dummy? It kind of rolls. It kind of rolls off the tongue a little bit. That's not the tone that's intended, but it's a tone that can be interpreted. We say this function loads all possible pantries in memory, even though you only loop through one of them at a time. Through them one at a time. Consider using a generator to yield them on the fly. Dummy. It doesn't fall as nicely. This is a sign that this is a more positive or harder to negatively interpret style comment. If you just say things like bad, students will take that feedback to heart. At the end of the day, as educators, when students fall short, which happens, our goal is not to berate them for falling short, but instead to help lift them up. And the language and the dummy test here, some of these other examples, can also be a good heuristic, a good rule of thumb to filter out your comments as you're writing them to students. To take a quick case study, my class, CS41, had a couple of assignments. This quest, which I got called out for, totally true. The quest for the Holy Grail, being Monty Python, had students running around campus to accomplish different tasks in Python. So we had a night class, and people had a name for their night. And some students submitted code, they've later given me permission to use this code, where they wrote a getName method. Never mind that our test harness never called a getName method. They just thought it would be appropriate to have a getName method. These are people who are coming from the land of Java. And we may say something like, function names should not be in camel case in Python. Maybe I should comment on that as style code. We can also identify just the whole use of a getter as something that's in some sense non-Pythonic. In Python, we just want them to access attributes directly if it's something that's readable. So as educators, we want to look at this, this world and always ask ourselves, are the comments we're giving productive and necessary? If a student's code is littered with lots and lots of these sort of stylistic violations, you just want to focus on the most important ones. And being able to identify which ones are more important to changing a student's way of thinking in line with Python, and which other ones they can resolve themselves, is a really challenging task that I'm leaving everyone with. As another example, we have a recipe book assignment where all the starter code is perfectly functional, but it's written as poorly as I could possibly make it, and their goal is to fix up the style. At one point in the starter code, we have this. We're starting some sort of constructor. We're just taking in a bunch of arguments. The specification says we can take in some arguments, and then assigning a bunch of values. This is terrible. This is stylistically weak. And I think one of the challenges here is to identify, if you saw this code, what you would do. Would you say, oh, maybe this is an opportunity to talk about object inheritance in Python 2 versus 3? Or maybe there's this big problem of not quite understanding Python methods and why we have self. Or there's also the spacing thing. We could talk about the spacing. And in Python, it's important to explore these different ideas, and as an educator, keep track of which ones are most important. I also think this resolution can be helped by considering the levels of your students. Are these original, are these first class Python students? Are these people who have a huge amount of experience, professional level experience in other languages, but are just coming to Python? We can tailor the style feedback we give based on what we know about these students' levels. So for example, if you had some sort of basic student, you might see code that looks like turning this list into some string. We'll add all the words with spaces afterwards and then remove the final space at the end. This is okay. Right? This gets the job done. But there's a better way to do this in Python. You can just join the list together. And this is a place where, for a wide variety of students, this might be something you comment on. This is a nice place where you're really seeing Pythonic utilities simplify code that may have been more complicated if you're thinking about solving problems with other mindsets. Maybe if you have some intermediate students, you could have some loop over dictionary where we're trying to get a word length to all of the words of that length. So go through each of our lexicon and try to add it to a dictionary. If you're familiar with other languages' data structures where maybe there's no auto-instantiation, you want to make sure, first off, if the length, the key isn't already there, I'll put it in with an empty list and then later go and append to it. Python has a built-in utility for this. Does anyone know what it is? Default dict in the collections module. This is a chance to just directly auto-instantiate with whatever factory function is passed into the default dict class some object. And this is a little simpler, but this is a more subtle difference that you may not bring up to your most basic students. And even the most advanced students here can sometimes have subtle changes. If someone's looking for some needle in an expensive haystack, and their expensive haystack is a list comprehension, the expensive function will be evaluated for all the keys before that containment test is run. So this may be an opportunity if you're working with advanced students to talk a little bit about list comprehensions and generator expressions. Saying, if we have some generator expression, we'll only be computing this expensive function on the fly until we find a matching needle. It may end up being the same amount of work if the needle's not contained. But if the needle is the same as the first result of expensive function, we'll only have to compute that once. The main takeaway from this section is when you're looking at student feedback and when you're trying to decide which of those many different stylistic points you want to bring up with students, you can use the student's level or the intensity of connection, the time you have with them, the resources, as indicators for how you should choose to give this feedback. So just to recap, style feedback should just help students think Pythonically. That's our big takeaway here. You should be cognizant of the biases that students bring to your classes, that colleagues bring to the workplace. Understand the languages they are most familiar with. Understand the other courses that might be offered at your school. And the three pillars of Python practice here, feedback here is, again, the practices, the design, and the mechanics. And really, if you're trying to bring people into the Python fold, you should just use Python practices more than the other two. Your feedback should be active. It should try to target specific existing biases, and the comments should be kind of scoped around. Thank you, everyone, for listening. That's all I have. And if there are any questions, I'll be happy to take them.
We have 2 minutes for questions.
Yes?
How do you deal with student frustration after feedback?
Student frustration after feedback is a big problem. Sometimes students will see feedback and be like, I don't agree with you. I think this is the right way to solve a problem or something. I mean, in certain cases, the student will have like code that fails on an edge case because of some complication. In that case, the discussion we usually have is about Python's strong opinions. Saying that like there is a Zen of Python built into every distribution. There is a fundamental philosophy to Python that you don't necessarily find in other languages. And it's true, solutions to problems can be easier in one language than another. But usually I'll say something along the lines of that particularly in Python, Python has decided that these are the most maintainable, most future-proof, most readable or elegant solutions. And usually a student will agree like one is more readable than the other at the cost of performance. And then we'll assert that readability is more important than performance or something, depending on the scope of the project. Usually that resolves student concerns. I mean, sometimes people will storm out of office hours. But it's a reasonable balance for students to come in and meet. Cool. Any other questions? Great, thank you.